All right, so on to number 4. Automobile engines were once measured in cubic inches, but are now measured in cubic centimeters. Susan's car has a 200 cubic inch engine. And if 2.54 centimeters is equivalent to 1 inch, approximately how many cubic centimeters is this? All right, so that's a lot of words. Let me summarize. 200 cubic inch, 200 cubic inch, convert to cubic centimeters. 2.54 centimeters is 1 inch. All right. How do we do this?
You cube the 2.54 and then multiply it by 200.
Cube the 2.54 and then multiply it by the 200. Does that sound like a good plan? Take the 2.54 to the third power and then multiply it by the 200? Or should we divide? So multiply or divide? So multiply?
Yeah.
How do you know?
Because if you have 200 inches, then you have 2.54 centimeters.
Good. I like the way you're saying that. Yeah, because every inch is 2.54 centimeters. So if you have 200 of those, then you have that 200 times. Good. I like the way you're thinking. Yeah. And what about what about cubic inches, and these are regular inches, and cubic centimeters, these are regular centimeters. Does that mean we do third power? Do you do on the units the same thing that's on the numbers? Should I answer some of these questions? So, you guys taking chemistry? That's where I learned it. It wasn't actually in a math class. I learned to convert units in Chem 3A. I don't know if you've taken that thing. They call it, I just heard that, I wouldn't know it, but I just heard the name. Isn't it stoichiometry? Isn't that the changing of units? That is right? Yeah, I was just at on Friday, right after our class on Friday, there was a conference here of teachers talking about the different ways to teach anyway, and I sat next to a chemistry professor from, I think it's from Burbank, CSU Burbank, anyway, and he was talking to me about stoichiometry, and he was showing me examples of how he tries to help students learn to convert in chemistry, and I was telling him that's exactly what I learned to convert, was chemistry. Anyway, so let's do that. Let me lay it out for you. I want to try to lay it out in a way that's really simple. That is my job. And so here's what I learned to do that made it, because I actually didn't get it at first when my Chem 3A teacher taught it. I didn't really get it until after the exam. That's always kind of a bummer, huh? You want to get it before the exam. I mean, I did all right in the exam, but I did it like a total hard way. And then right after the exam was over, he was like going over the exam. Maybe I should go over exams. He went over the exam, and I was like, oh, I see. It's easy. Once I got what he was saying. So let me try to do that for you right now. It's actually really easy to convert units. The main thing is you want to start with, whatever they give you. We're starting with this. That's what we have to begin with. So 200 in cubic inches. Now you want to make that look like a fraction. So just put it over 1 because it's all going to be about fractions. Okay? And then put down your goal, what you want in the end. In the very end, when all is said and done, if the answer's 7 or 17 or 700 or whatever the answer is, it's what units. What units do I want in the end? Cubic centimeters, huh? Convert to cubic centimeters. That's my goal. That's my final destination, right? Cubic centimeters. Good so far? Okay. So now whether you multiply or divide, you all are thinking right. You're thinking it's a good thought about the 200, the multiply, and stuff like that. And that's how I did my chemistry. I would kind of think it like you guys are. But you know what? You don't actually have to think that hard. That's what I realized after the test. It's like, oh, you don't even have to think hard. Although you're thinking well hard. But you don't need to do that. All you have to do, this is what I didn't get till after the test, is every time you're taking your next step to convert units, you're always motivated by what you want to get rid of. What do you want? So right now, I have cubic inches. I want to end up in cubic centimeters. So what do I want to get rid of?
Inches.
Well, cubic inches. I don't want them in the end, right? I got them now. I don't want them in the end. I got to get rid of them. So if I'm going to get rid of them, it's a fraction, right? Going to cross multiply. So where am I going to put cubic inches? I mean, cross cancel. So where do I put cubic inches? Down below. Now let me put just regular inches for the moment, and we'll talk about the cubic thing. But yeah, I know I want to put inches, and in a minute it'll become cubic inches, on the bottom because I got to get them to cancel. I don't want inches on the top. That'd make more inches up there, right? I want to get rid of inches because in the end, I don't want them. In the end, I want it to equal cubic centimeters. So you put down below whatever you want to get rid of, okay? Now how do you know what goes on the top? Well, what do you got? I mean, what choices do I have? Inches is, right, equal to, same as, 2.54 centimeters. So that's the only relationship I really have. 2.54 centimeters for 1 inch. Now, do you see how I wrote that? And I didn't even have to think hard about, let me see, inches are smaller or centimeters are smaller. So, that's what I did the first time. It was hard. You don't have to think about all that. You just go, look, I want to get rid of inches, put them on the bottom, and I'll make it third power in a minute. And they're telling me 2.54 centimeters is equal to, same as, 1 inch. So 2.54 centimeters, 1 inch. These are the same thing, that means, right? Meaning this fraction I'm multiplying by is a fancy 1, in other words. You tracking with me? How do I know that? Because what is this 1 inch the same as? 2.54 centimeters. This is 2.54 centimeters over 2.54 centimeters, really, isn't it? Right? No.
Would it work if you still put the 1 on top? That way you put your inches on top and the centimeters on top?
Wait, the original one?
The other one.
This one? If I put the 1 on the top, like, and you mean leave the units? Good question. You leave the units where they're at?
You put the units too, so put the 1.
Oh, okay, gotcha. Yeah, so if you put the 1 inch on the top and the 2.54 centimeters, that is still a 1. So to answer your question, that's still a big fancy 1. So in a sense, well, in this sense, in the sense that we're not changing a value, it is okay. But it's not okay in the sense that it won't take us where we want to go. In other words, let me say it more clearly. It's kind of like this. So this is not illegal in the sense that it's okay because these are the same thing, aren't they? So they are a fancy 1. Is everybody tracking with me on that? It's like when you take a fraction. You say, hey, I've got, 3 sevenths. Excuse me. And I want to multiply top and bottom by 2, and it becomes, 6/14? That's supposed to be a 14 down there. That's the same thing. I didn't change that fraction. I just changed the way it looks, right? I could reduce it, divide by 2 top and bottom, and it would go right back, huh? You with me on that? You know what I mean by not changing it, not changing the actual value? So Noel's question is a really good one. If I multiplied this, it's legal in the sense that it doesn't change the value, but it's not helpful in the sense that it doesn't get me where I'm trying to go. What do I mean? Well, because then it would be inches cubed times inches. What's that? What's x cubed times x? Remember from algebra? What's a third power times the first power? Same thing. It's fourth power, huh? This would be inches to the fourth over centimeters. Is that what I want to end up with? No. So it's legal, but I think I said this before. It's like driving around your block 10 times before you pull into the driveway. It's not illegal. The police won't pull you over and say, you're stupid, don't go around the block 10 times. That's not illegal to be stupid like that. Right? I make a lot of U-turns. I'm terrible with directions. So I do a lot of crazy things. I am one, it's not false humility. I literally am one of the worst in the world about directions. It's funny. I'm good at math and science. But it shows that there's different kinds of intelligence. My wife and I fit the opposite stereotype. My wife has to tell me where to go all the time, and I appreciate it. I'm anxious. Well, of course, I use I love technology because it tells me where to go. I could get lost. I could tell you many, many, many stories. But this is, to me, the funniest one. I had a buddy that I drove with. It was like 20 years ago. Him and I commuted to work together. And I said to him when we started, hey, you know what? I'm really bad at directions, so you just tell me where to go. It's all good. He's like, oh, no. I said, no, I may be the worst in the world. I said to him. He's like, no, you're just da-da-da-da. After we drove together for a couple of months, he's like, and I kept asking him the same thing over and over. He said, you may be the worst in the world. So why did I tell that whole story? Because, drive. So my point is I really want to answer Noel's question clearly. It's a good one. This is not illegal. But it's driving in circles, right? It's okay, but it doesn't get you where you want to go. Where do I want to go? Cubic centimeters. So it's okay in the sense that it's a fancy one. You're not changing any values. It's okay to do it either way, legally, but you want to get somewhere, right? So where are we trying to get? You want inches on the bottom because you want inches to go away and then to end up being, so I put in what it says, 2.54 centimeters is 1 inch. But I got to cube it, don't I? Because I want third power. Good, I have to. I got third power. They started me off with third power. So what do? Exactly what you guys were saying. You were right on the money. You just third power this, third power that, third power this, or you could just do one big third power, the whole thing. Yeah, maybe that's, whatever. Just third power them all. And then cubic inches, we'll cancel cubic inches. What am I left with? What's the only units left standing? Cubic centimeters, where I wanted to arrive. And see, I never thought hard about big things, small things, all that, like I didn't get first time. So it's so what do I do then? So when you've got that all laid out, it tells me take the 200 and multiply by what? 2.54 to the third power, just like a few of you said right in the beginning without all this talk. That's right. But this works even when things get super hard with miles per hour to kilometers per second and crazy things. It's just as easy if you understand the steps every time what you want to get rid of. So somebody have that on their calculator? Or I can get it if you don't have it. 4128. Yeah. Cubic centimeters. I don't know how far they want us to round. What did they say? Round to the nearest cubic centimeter. So they just want whole cubic. So 3277 cubic centimeters. Make sense on that? That's how you convert any units. Any units. I think Math 10b, the next one, talks more about converting unit examples. Anyway, but there it is. Chem 3A. Extra bonus. No extra charge here in math class. A little bit of chemistry. All right. Let's go to number 5. So same kind of thing. U.S. $1 bill, 0.8791 Chinese yen. Okay, so let me write it down. So $1 is equal to, what did they say? 0.8791. 0.8791. Did you say yen? Is that yen? Yuan? It looks like, I don't know. Whatever it is. What is $20.22? American, okay. So, wait, 2022? Yeah. So $20.22 is how much, whatever those are. Yuan? Does anybody know? All right, whatever those things are. So, can we do it? So you don't, again, this is a 1 here. 8791, right? 0.8791. You don't need to think hard about, that's what I did. I didn't get it first time I was doing chemistry, and I would think hard about littler to bigger, and don't worry about all that. Don't need to think that hard. Just write down what you're starting with. Oh yeah, what are we starting with? That's the conversion. We start with 2022, huh? We start with $20.22. That's what they're giving me to start with. And in the end, what do I want? How many yuan or whatever those are? All right. So we good? So notice what I do. I write down the starting and ending points. So when you want to convert any kind of units, this works on through physics in really hard conversion problems. You write down what you're starting with, what you want to end up with. And then you just, and this is over 1, right? Then you make the connections along the way by what you want to get rid of. So my next step, how do you know what to do next? Well, it's what you want to get rid of. Dollars is a type of unit.
So would you put like...
And by the way, let the units lead the numbers. In other words, don't first write a number. Notice I wrote dollars. I didn't even have any numbers yet. Let the units guide you to the right numbers. Before I took, physics, I didn't like units. They kind of bugged me. I wish they weren't there. When I took physics and I had crazy hard word problems everywhere, that's what physics basically is, I was so glad that I learned how to deal with units, because then the units would often, I'd read some crazy word problem and have no idea, and then I'd go, I don't know, but look at those units. If I take this unit and flip it and move this one here, and these will cancel, that they want cubic centimeters per foot in the end, so that would be that. Maybe that'll work. That'd work about half the time. Half the time, I wouldn't even know what's going on. I would just follow the trail of the units, and things would work out. Other times, you needed to know more. But anyway, so just follow the units here. Literally, you don't have to know anything. Just follow the units. Dollars on the top. Got to put dollars on the bottom. I want dollars. I don't want dollars in the end. So dollars have to go away, right? So they got to be down there. Now, once you write dollars down there, you go up here and go, what could I convert dollars to? What do I know dollars are connected with? Right here it says $1 is 0.8791, whatever those things are. So I go, okay, $1 is the same as 0.8791 yuan or whatever those are.
Yuan, like the ending is en.
So say it for me.
I don't know. I looked it up and it's like a yuan.
Yuan?
I don't know.
All right, we'll keep moving. All right, so makes sense how I did that. I just simply wrote dollars on the bottom because I want dollars to go away. And up there they told me the connection. $1 is 0.8791 of those things. So dollars, that was what was news to me in chemistry. The units cancel just like numbers do. I didn't realize before Chem 3A. So those cancel. So then, and so that's it. So then you just use your calculator. 2022 times 0.8791. And so, when we got that, is it 19 something?
17.7.
17.7. I don't know how far they want us to round. What do they want? Nearest hundredth. So I need one more spot. 17.77? Doesn't round to 8?
Yeah.
It runs to 8 because the next digit is 5.
Okay, 7.5. So 7.5. So it rounds to 17.78 yuan or whatever they are. There we go. So it's not always multiply, though. It's too bad that twice in a row it's just been multiply. But sometimes it's divide when you convert units, right? How will you know if it ends up on the bottom? Basically, if this number had ended up on the bottom, it would have been divide. If it ends up on the top, it's multiply. You don't worry about it ahead of time. You just follow the trail of the units, and the numbers go where they go. All right, let's see another one. How about, well, that's it for now, I guess. Okay, we're going to convert to decimal. So 8.66 times 10 to the 6. So number 6. 8.6 times 10 to the 6. Convert to decimal. All right, so do you remember what in the world does that mean? What's that called when they do it that way? Scientific notation. Yeah, I've seen that before. Scientific notation. So, what do you do with 8.6?
Right? Because it's a whole.
Exactly. You take the 8.6, and this means you go right 6 places. If that was a negative 6 power, I would go left 6 places. So take the decimal, first jump, and you're to the edge, All the rest of the jumps, what are the rest of the jumps going to do? Going to add zeros, So that's 1 jump, 2, 3, 4, 5, 6. So the other 5 spots bring in zeros. Right? 5 zeros end up bringing in, right? So the first jump we get over the 6, and the other 5 jumps bring in zeros. So we have 86 with 5 zeros, which is, what's that number? 8,600,000. Yeah, so there it is, we're done. They just want me to convert like that. Is that good? And then write the numeral distance between 2 planets. Okay, 26, whatever that is, big number. 9 zeros. Okay. So number 7. 26 with 9 zeros. Convert to SN. Don't they want me to convert? Let me double check. Yeah, convert to scientific notation. Okay. So there it is. What is that? 26 what? It's billion, right? Because if it was right here, it would be million, wouldn't it? That'd be 26 million. But it's a spot bigger, so it's 26 billion. All right, anyway. So what is SN? What is scientific notation? I'll give you 2 rules. Where's the decimal go in scientific notation? Yeah, after the first digit that is not 0. So the decimal goes after the first digit that's not 0. So 2.6. We put the decimal right here. and then times 10 to some power to move the decimal back where it really belongs. So you're tracking with me? So that's scientific notation. Decimal after the first digit that's not 0 times 10 to some power. Tell them the decimal to go back where it really belongs. Now, what do I mean go back where it really belongs? Well, I put it between the 2 and the 6 because that's the notation's rule, but that's not where the decimal really is. Where is the decimal really? Yeah, you know, it's right there, huh? So how many places to the right is that? 10, right? Because 1 and then 3, 3, 3, 1 and 9, 10 places, so times 10 to the 10th. Does that make sense? If you took this number and you went 10 to the right, you'd have that number. So these are two languages saying the same number, like me saying 1 and uno. I'm saying the same number in two different languages. I'm saying 26 billion in two different languages, right? Regular, we call this decimal, base 10 system, call this scientific notation. Two languages to say the same number. Why in the world did science make up this crazy way of saying things? They made it up, like all of math. It's all just made up.
For really long numbers.
Yeah, really big or really small numbers, right? If you're dealing with a really big number, like how far away planets are from each other, or like you're doing cell biology and you're measuring the width of some, super tiny thing or uranium atom, you don't want to say it's 0.000000000000371 meters. Like, wait a minute, how many O's was that? It's just not a better notation is 3.71 times 10 to the minus 8. It's a much more clear way to write super big and super small numbers. So they made up this for super big and super small numbers that some scientists deal with. All right, so let me write here for you. What is it? 5 times 10 to the 14th. 5 times 10 to the 14th times 3 times 10 to the 17th. All right, they want me to, we're multiplying, huh? And answer it in scientific notation. All right. Answer in SN. So answer in scientific notation. Talk about it. So first off, on this problem, it's important to distinguish between what is true and how something looks. So let's try to keep those two categories real straight in our mind. So first off, the rule, 3 times 5 is 15. And then what do you do with powers? Atom, 31. But you remember that rule, like x squared times x cubed is x to the 5th, right? Because that's 2 x's, that's 3 x's, there's 5 x's, right? Same way there's 14 tens and 17 tens, and that's 31 tens. Good. So far, so good. That's what's true, but it doesn't look the way we need it to look right now. They're making us, when they said make it in scientific notation, they're saying give it a certain look without changing the value. That's so much of math and science. It really is. Making things look different without being different. I always, when I teach pre-calc and stuff like that all the time, I always call it plastic surgery. Removing the wrinkles so the person looks different, but it's the same person. I just want to say some weird word so I make sure they're not like zoning out. So they really get, and I think that word is descriptive and helpful for them to grab what we're doing. So much of what we do in math and science is plastic surgery. We don't like the look here. We want to remove the wrinkles, give it a different look, but we're not changing the value, right? We have to do it in a way that preserves the value, keeps it the same value. So, okay, now what, and you know what look we need. We need the decimal right there. That's just the rule. They just said, make it look like that, right? Or you're not in scientific notation. That's the rule. Okay, I have to make it look that way, but I may not change the overall value. So, times 10 to what power? So that overall, the value's not changed. 32 is correct. Do you see that? Now, why? Well, a couple ways. I liked it. A couple ways you guys said it was good. I hadn't thought to say it that way. Some people said, well, here's a good way. I liked it. Some people said to me, think about what this number is. It's 15. Where's the decimal right now on the fifth? I don't see a decimal. Where's the decimal? It's at the end, right? It's at the end. Like a period in a sentence. If somebody forgets to put the period, you know where it is. 15. And then 10 to the 31, what is that? 31 zeros. We all agree? 15, 31 zeros. So that's the true number. That's the real number. So I've got to make this be the same thing. I can't change the actual number, just the way it looks, right? Plastic surgery, just the way it looks. So if you do 32, then the first jump will get it to make it a 15 again, and then you'll have 31 jumps left to bring 31 zeros. So those are the same number, aren't they? That's a good way to say that. I normally say it a different way. I like the way you guys were saying it. That's a good way to show those are the same. The way this might help too, so I'll say my normal way. I'll say, look, if I want to overall not change this, think about what did I do when 15 became 1.5? Did that make it bigger or smaller? Just the 15. Forget about everything else. Just if I say, hey, do you have 15 pies? No, I have 1.5 pies. Which one's bigger? Well, clearly 15's bigger. So what did I do to this? I made this part smaller. So if I overall want to change nothing, what do I got to do to the other part? Make it bigger. That's what I usually tell people. If you make this smaller, then you got to make that bigger so that overall you've done nothing. That's another way to think of it. But I like the way you guys are talking about it. Just think about how many zeros. That's good. Good on that? So you have to do that a lot with scientific notation. It's all about changing the way it looks without changing the value. All right. Here we go. Can you try that one? That one will be quicker, I think. Nothing fancy at the end. So we're dividing. If you want to write it vertically, you can. I mean, you don't have to, of course. It's the same. It's the same thing as this, isn't it? You don't have to write that, but if that helps. Exactly. So yeah, what do you do with the numbers in the front? 16 divided by 4 is just 4. What do you do with these powers? Subtract them. Yeah.
It's 15 now.
Did I do something bad? Oh, it's 15. I changed the problem. Yes, thank you. I'm messing up there. 12, right? Yes, that's it. You know just how tricky I am. All right. And can I leave it that way? Is the decimal word supposed to be?
Yes.
Yeah, that's right. It's after the first digit. You can write 4.0 if you want, but you don't have to. That's good, right? The decimal's supposed to be after the first digit. It is. So it's all good. I don't need to do any fancy plastic surgery. That one already has the look we want, doesn't it? We good there? So you subtract powers, right? You know that rule, like if you have x to the 5th over x squared, it's because there's 5 x's, 2 x's, they cancel, right? That's why, this is 15 tens and 3 tens. They cancel, there's 12 left. Remember all those rules from algebra? All right, so let's try now. C is the same thing. Yeah, let's move on. We're good, let's move on. Okay, so number 10. But we're going to take the same number and just round it to a whole bunch of different places. So first off, round to the nearest hundredth. Hundredth. So you want to do all those real quick? So how about just on your own? All right, so round to the nearest hundredth. So 100 has 2 zeros. That means 2 places to the right. So rounding, you can circle the spot and look 1 to the right. If the 1 to the right is 5 or more, you round up, huh? So 377.52. Does that make sense there? We're saying basically this amount of money is closer to $377.52, right? Than it is to $377.51. The 6 makes it, right? You can put O's here, right? 516 is closer to 520 than 510. That's what we're saying. You see that? Does that make sense? I want to make it real for you. So, okay, how about the next one here? So we're supposed to round where to the nearest tenth. So the 10 is just 1 0, 1 place to the right. That's the 10th place. Look, 1 to the right of that, it's a 1, just leave it. 377.5. Nearest unit, units means the ones place. Look, again, 1 to the right. So you always circle. Notice I'm just circling the spot. I want to stop. Looking 1 to the right. If it's 5 or more, you round up, huh? 370. So that'd be if I get 300. If the price was $377.51, that's closer to $378 than it is to $377. You tracking with me? See how that's rounding to the nearest? And then 10 nearest 10, that would be, that's the tens place, huh? Same deal. Look 1 to the right. If it's 5 or more, it is round up. Now, what am I going to round up to? 380. Yeah, because that's closer to $380 than it is, right? Rounding up would be 380. Rounding down would be 370. It's closer to 380 than 370, isn't it? 377, much closer to 380. That's round to there's 10. And finally, the last one, 100. This is the hundreds place. Look 1 to the right, 7 round up. What's the number going to be? Yeah, it's closer to 400 than it is to 300. It's got to be a 100 answer. We good on all those? Remember all that stuff? Questions?